Okay, so the next lesson is on using technology. Okay, so using technology part one. So what we're going to do is basically an intro to um, something called the TVM solver. Okay, you may have used this last year actually in Foundations 11. So it's just a way to calculate some compound interest problems. Okay, so but I thought to start off with some review. Okay, so I have actually this link here. I'm going to post. This is the one. The calculator we're going to use. It's an online version. Okay, so we're going to use this one as well. I'll post the link in the chat as well. Okay, so but before we get to that, we're just going to do a little bit of review from last week. I know it's been about a week. So just using compound interest. So for review, we want to calculate the future value of an investment. Right. So if you invested 8,000 at a rate of 3.5% per year compounded monthly for 7 years. Okay. So as review, the future value or accumulated amount, which is A. This is the formula here. Is the principal times 1 plus the rate divided by n times t. Okay, so we're going to start off with 8,000. So this is your principal, P. Annual rate of 3.5%. Okay, so that means R is going to equal 0.035. Okay, because in the formula, we got to write it as a decimal. If it's compounded monthly, that means that, we're going to write that, I'll write it up here. That means n is going to equal 12. And for 7 years. Okay, so 7 years here, that means that t is going to equal 7. All right, so those are the values we're going to plug into this formula. All right, let's see what we get as an answer. So A is going to equal the principal. Okay, so that's 8,000. 1 plus the rate, which is 0.035. Then we're going to divide it by 12. And then, again, we have n up here, which is 12. I'm going to multiply it with t, which is 7. Okay, so it's supposed to be a multiplication there. Okay, so A is going to equal, let me just take the calculator out. All right, so we have, so what I'm going to do first actually is the brackets there. All right, so let's see what we get. Bracket. Okay, so I'm going to go 1 plus 0.035 divided by 12. Close the bracket. Or no. All right, so we get this decimal here. I'm just going to 1.0029. I think it was 1, 6. Yeah, the 6 repeats. So I'm just going to write ... here. Okay, so the rounding itself we're going to leave to the end. Okay, so I'm just going to leave it in the calculator like that. Now up top here, 12 times 7. All right, so that is 84. Okay, so now since I have that number in the calculator, I'm just going to raise it to the 84th power. And then multiply it by 8,000. Okay, so the final amount there, $10,217. And what is cents here? 33 cents. Okay, so this is the final amount of that investment after the 7 years. Okay. All right, so that should be review from what you guys did in the last lesson. Okay, so what we're going to do is today it's basically just kind of getting used to this TVM solver calculator. We're going to be able to get these numbers here just by kind of plugging in the information into the calculator. So I'm just going to open that hyperlink. All right, so this is the calculator that's there. So let me just, actually, you know what, I'll split this up into two screens here. So just want to make sure I get the, get everything on the screen so we can read it. All right. Okay, let me just zoom in a bit here too. Zoom. All right, so that's a little better. Okay, so in the first example, all right, so what we're going to do is we're going to calculate the above review problem using the TVM solver. All right, so I should get the same value here. All right, but what I'm going to do is actually show you what you'd punch in to get the answer itself. Okay, so so again, this here, the present value, all right, so is the amount we're going to start off with. So in other words, it's the principal. And so in this case, it's going to be 8,000. Okay, so the next one here is payments, something called payments. Payments we're not actually going to look into for at least a couple lessons. All right, so payments would be like if you were to like contribute certain amounts of money, like you're basically adding into the investment over time. But in this case, we're just for this example, and what we've done so far is just one principal payment and then just kind of waiting for the final answer. So we're not adding into it. All right, so for today and for actually the next lesson, your payments will be 0. Okay. Future value is actually what we're going to try to find. So the annual rate was 3.5. All right, so this one here, periods. Okay, so periods is the number of times it's going to be compounded, all right, over the time value. So so in this case, since it's monthly, okay, so we're compounding monthly for 7 years. That means that, I'll just bring it up here, it's 12. So 12 times a year times 7 years is 84. Okay, so that's the number of periods. Okay, so in other words, actually, if you notice here, it's actually this number here, the exponent. Okay, so it's going to, for this question here, it's going to get compounded 84 times. All right, so that's what we're going to enter here. And it is compounded monthly. Okay, so I'm going to leave that there. Okay, so all you're going to do is over here, you just punch, since we're looking for the future value, we're going to click on this here. And you'll notice it says negative 10,217.33. Okay, so what ends up actually happening is that for these TVM solvers, the future value actually comes out to being negative, right? Just the way the calculation set up, right? Or the calculator set up. So now, if you look at it though, if you compare it to this one here, 10,207, we get the exact same answer. Okay, so this is just a formula. This is just punching the values into this TVM solver, this TVM calculator, and we get the same answer. All right. So again, we do get $10,217.33. Now the second part of this actually example here is we want to know how much interest. All right. So just so how much interest? All right. So interest is how much you make on top. So at the end of the 7 years, it's 10,217.33. So that's how much it's worth. We start off investing 8,000. So therefore, the interest earned, you're going to subtract it. So that's going to be $2,217.33. Okay, so just kind of a little bit of an added on, I guess, to this question. Cool. All right. So the next example, we're going to calculate how much money you would need to invest in order to have 200,000 in 15 years if the investment is paid at an annual interest rate of 9%, compounded semi-annual. Okay, so a lot of information here. First thing we want to do is actually see what it's actually asking. So how much money would you need to invest? Okay, so that's what you're trying to find. So that would be the principal. Okay, so we're being asked to find the principal. The final value, because we want 200,000. When it comes to 200, the final value, future value, sorry, we want to punch it in as a negative. Negative 200,000. Annual rate is 9%. All right, so now the number of periods, all right, we've got 15 years compounded semi-annually. Okay, so right over here. So 15 years, 7 compounded semi-annually is twice a year. So that would mean when I multiply it together, there are 30 compounding periods. Okay, so I'm going to put 30 in here. Okay, so compounded 30 years, and then this compounding, I'm going to have to switch it to semi-annual. Okay, so now questions asked to find the present value or the principal. Click on that. You can see that it's going to be 53,400. Okay. All right, so let me just scroll in. Okay, so the present value in this case, once we plug in into the TVM solver or calculator, I keep saying solver, TVM calculator, right? It is 53,400. Cool. All right, so let's go on to the next one here. So what's the annual rate of interest, or what annual rate of interest? Okay, so we're being asked to find this value here. And so I'm just going to delete that. Would you need to have from an investment in order to grow 5,000 into 30,000? All right, so 5,000 is my principal. Again, the future value, I'm going to plug it in as a negative, so negative 30,000. So we are trying to find the rate, and it's over 15 years, compounded quarterly. Okay, so the periods, the number of periods would be 15 times 4. Okay, because quarterly is 4 times a year, which is 60. Okay, and this is, I'm going to switch that to quarterly. The annual rate, okay, so would have to be 12.1%. Okay, so R in this case, R equals 12.1%. Okay. All right. So last example, how many years would it take a CD to double in value? Okay, if the interest earned was 8% compounded weekly. Okay, compute this using the rule of 72, and then the finance application. Okay, so in other words, the TVM solver. So we're going to just kind of compare. Okay, so if I use the rule of 72, all right, so remember the rule of 72 tells you how many years it takes to double given a rate. So T is going to equal 72 divided by the interest rate, which is 8%. So it should take 9 years, approximately. Okay, so again, rule of 72 is an approximation. So I take 72 and divide it by the rate, and that should give you the approximate number of years it takes to compound. All right. Now, since it's an estimation, whether it's compounded weekly, compounded monthly, compounded annually, okay, it actually doesn't matter. It doesn't affect your estimation. All right. So we're just going to use this kind of as a general rule. Okay, so it should be close to 9 years. And now we want to use the finance app. So we want to use this TVM solver to actually get the actual value. Okay, so now if my present value is, and you can, I'm going to just use $1. Okay, so 1, and then it's going to double to 2. All right, now I know that's not really, realistic or applicable, but as long as you put a number here and then the future values double it, you should get the same answer. Actually, you know what? After I'm done using $1 and $2, I'll change the values and just show that it's going to be the same. All right. Okay, so now we want to know, again, how long. So we're looking for actually the number of periods. All right. The annual rate was 8%. And it's compounded weekly. Okay, so if I calculate, it says 450.89. Okay, but that's the number of periods. All right. So periods is the period itself. The number of periods, I'll just put a line there, is 450.89. Now that's not the number of years, it's just the number of periods. Now, since it's weekly, to convert it to years, I'm gonna have to divide this by 52. Okay, so the 450.89, I don't know, that's terrible writing, is the number of weeks. Okay, so to convert it to years, I'm going to divide that value by 52. Okay, so 450.89 divided by 52 gives us 8.67. Okay, so this is equal to 8.67 years. Okay, so that's the kind of like the exact value. This, again, is pretty close to the approximation, which was 9 years. Okay. Okay, so again, I'm just going to kind of show you, it doesn't matter if, as long as whatever you put in as a present value, so I'm just going to go back to this. Let's say, I don't know, 40,000. Well, double that would be 80,000, so I'm just going to put negative 80,000. Again, I'll delete this, and just to show that when I punch it, I should get the exact same number. Okay, so as long as this present value and the future value is double the present value, you should get the same number of periods. Okay. Cool. All right, so that's the examples I have for today. So the assignment is 1.3, worksheet number 2 to 7. So I'll just open that up here. Okay, so we're on to 1.3 here. And so, yeah, so don't worry about this number 1. Okay, maybe just a little bit of background here. Notice it says TI-84 calculator. Okay, so since I didn't want you guys to bother going out and buying a calculator, because the two things that this code calculator, the graphing calculator that is quote unquote required for this course, the only two things that it actually does is it graphs things that we did in the class before spring break, but we use Desmos for that. And the other thing that it's useful for is this TBM solver, which is programmed with the calculator. But since we have the old internet, we can use you can use that website. All right. Yeah. So number 1 here, this is you don't have to do this question because this is the kind of the input screens for the graphing calculator. But you're just using the web-based TBM solver that I use in this lesson. Okay, so just go do numbers 2 to 7 for practice. Cool. All right, guys, have a good one.